Right, welcome everyone. As everyone's jumping in, I'll give a couple of minutes to come in. While you're waiting, Amy might pop up a poll that you can complete just about where you're listening from today. Thanks, Amy. A few more just coming in. Just click on the poll if you haven't already, where you're listening from. So you're sharing all of your screens?
You know, I was just
Oh, yeah.
just having a flick. Damn, only having one screen. I don't know what's going on the other side. Even know if I'm centered to my camera. Anyway, just...
Okay, we've still got people coming in. I'll give it one more minute and then we will kick off.
we are recording, are we?
We are recording. Just be aware everyone will be on mute unless we ask you to come off mute. So that will happen automatically. So don't stress about that. Well, someone's doing it from the tractor. Good effort. Watch out for the power poles. Okay, 12:33. We might begin. I'll just get rid of this poll here. We are recording, just for your information. All right. Good afternoon, everyone. Welcome to our first Friday Climate Forum. It's part of our new webinar series being delivered over the next couple of years through our Eyre Peninsula Sustainable Ag Program, which is run in partnership with the Eyre Peninsula Landscape Board and funded by the Australian Government. So today's session is focused on the seasonal outlook for the EP, and we're very pleased to be joined by Dale Gray, Seasonal Risk Agronomist with Agriculture Victoria. Welcome, Dale. Dale will talk us through historic timing of the break. He's done a few stats, the current soil moisture, key climate indicators, and what the models are suggesting for the next 6 months, which is what we're all keen to hear. Dale will also unpack what the current discussion around a super El Nino means and what it may not mean for Eyre Peninsula farming businesses. And before we begin, a few quick housekeeping notes. Just please keep your microphones muted unless invited to speak. You can submit questions either through the chat function or the Q&A function. So we'll keep an eye on those, Amy and I in the background. We will probably hold questions until the end, but we will allow plenty of time for questions. And also, if you've got suggestions for future topics, we're really keen to hear those. You can email them to me, Naomi Scholes, at any time or when you register for the next event. That'll be great. So I'll now hand over to Dale. He will lead you through for the next 30 minutes or so. Thanks, Dale.
Fantastic. Thanks, Naomi. And It is good afternoon over there. It's good afternoon here in Victoria, in Bendigo, in the centre of Victoria, not necessarily the centre of the universe. What I have undertaken is some manual calculations of the timing of the break, looking at the daily rainfall from a couple of locations, from Yalana and Woodna. And people will all ask me, what rule are you using to work out the break, Dale? And well, it's a bit difficult to describe because every year is different. And, probably 90% of the time, it's absolutely obvious when the break has occurred. There's been enough rain, there's been enough follow-up. You can see that absolutely crop and or grass would be growing. But some years are much more difficult than that, where you kind of go, well, did it get enough to germinate? Has it been too long between drinks? So, probably 10% are probably perhaps debatable, but the majority I think are not. So what I've got three slides here for Woodna. This is just looking at the timing of the breaks. This is perhaps a bit presumptuous. If it keeps raining, it probably would have been the break, which is not the earliest one on record, but you can see there was a run of 2011, 12, 13. There was quite a run of earlier ones there. And then the most two recent years, 24 and 25, are right up that kind of other end of being much later. I think this graph is really interesting because it's quite different to the ones I do in Victoria, where they're perhaps more normally distributed and we have quite a decent June, July tail in our drier parts of the state. Whereas you've got this very distinct May drop-off. Once you get to the end of the May, it's nearly always rained in most years up there in Woodna. And then I've put in some of the false breaks and occasionally the double false, where you actually get two starts, usually when they happen earlier, certainly in February, but sometimes in March. And then you don't get enough rain, and you get another rain, you don't get enough after that either. Not all that common. But the next little graph here is a 5-year moving average of that data, showing where the average is the median is the 4th of May, so centered around this line here, showing that sort of bounced around, but it really shows a period in the 2000s, I suppose, where the timing of the break was much earlier than normal on average. And then in the recent sort of 7 or 8 years, it looks like it's kind of perhaps come back to something a bit more normal. This is just a histogram distribution of that data, showing the number of false breaks in red and the breaks in the months, the weeks of the month down the bottom, showing that long-term median is the 4th of May. But if we look at the last 25 years, it's considerably earlier than that, earlier than Anzac even at the 21st of April. And some parts of southeastern Australia, the most recent timings of the break's been a bit later, but a couple of locations are earlier too, and yours looks like one of them. If we change now, go down south to Yalana, a very similar shaped graph. Once again, it's all about April, May, February, March, not common, June, July, not common. So I would term that relatively reliably May. A few less double false breaks there, a few less, perhaps not a few less false breaks, but a few less double ones there. The graph where the average is, the median is the 1st of May, so today is the median day of the timing of the break as calculated by me anyway. And perhaps not quite certainly not, you can still see that swing there earlier in the 2000s that went down. And then the histogram showing that the median is the 1st of May, and in the previous 25 years, the median is a touch earlier than it, maybe by a week or thereabouts. But it really does show that sort of cliff drop off there once you get to you don't do June breaks over there, which must be a marvellous thing, given that and difficult when they actually do happen, because historically you wouldn't be planning them for that often. Rightio, let's now look at that's the timing of the break stuff. Let's now go down to some recent history. So January to March rainfall, as we know, it was decile 10 over a lot of the area, highest on record in some parts in the dark blue here over on the northwest coast. but not everywhere. And down south was closer to normal. There's sort of 100 to 200 mils in this kind of area bounded here, but only sort of 25 to 50 in the southern tip for that January to March period. The April rainfall has just come in, not overly exciting, a little bit of above average in some parts with 25 to 50 mils up there in the northwest and down sort of, well, probably that western coast all the way down to the tip. Probably agronomically useful, I would say, but 5 to 10 mil over in the far east, not so useful, and a bit, probably a bit nuff through the rest of the middle, I would suspect. Temperatures, I haven't got April temperatures through yet. They were warmer through January to March, 1 to 2 degrees, so decile 8 to 9 in the yellow, and 1 to 2 degrees warmer on average for that 3-month period through this region here. And minimum temperatures were also warmer than normal. Decile 8 to 9 in the yellow, decile 10 in the orange, and 1 to 2 degrees warmer in terms of minimums for those northern parts that I've marked, delineated in red. Now looking at stored soil moisture, this is the modelled stored soil moisture map from the Bureau of Meteorology. We think this works, at least looking in Victoria, works the most if you think of a perennial pasture growing. This model loves using water when it rains, which is not what croppers do, we know, and so therefore we get some different analysis and data when we look at actual measurements. But in terms of the model, of course, it was incredibly wetter than normal. That's really just now in the far northern parts, certainly deemed to be modelled to be wetter than normal in the far west there, Yellada and thereabouts, but much more closer to normal over most of the Eyre Peninsula. If we look at our soil moisture probe network, for which you have a very excellent example of one, many of those probes jumped up to what would probably be their upper limits through February, March, which is always exciting to get to the highest, wettest point. And they certainly mimicked the probes that have been going long enough, mimicked the times where that, I think it was 3 years ago, where it also wet out to be very wet, sort of more middle of the season in August. So reaching similar values, so that's always exciting to see repeatability. And we had a lot of probes at that time, a month ago or more, which had jumped up into the 75 to 100% plant available water full, but they have drained and evaporated. They're probably grown. Some of them are definitely growing some stuff on them, I can tell, because the rate of loss has been more rapid. And so, some probes are still sort of sitting there in the wetter end of things, but, others have sort of come back to still wetter, still wet, but more modestly so, the sort of 50 to 75 in green. And a few of them have even ducked down sub 50%. And as we get further south here, where they haven't had the rainfall, things are lower. If we look at the changes to date, we can see that in the north, a fair number of those probes have decreased more than 10% in the last 30 days. I know there's a couple there that have decreased by about 40%. There's definitely something growing on those, but most have sort of come back by around 10 or 11%. That could be modest plant water use, but it could be just evaporation or drainage as well. And also a lot of probes have sat doing nothing, sat there on the fence. And one would imagine if things haven't been planted, things were certainly sprayed out of those paddocks and they wouldn't be using water much anymore. The dangers, of course, though, when someone's providing intelligence from Bendigo on somewhere that's a long way away. From space, this is greenness. This is NDVI, an anomaly, where if we're the white colour, it's completely normal. If we're greener, it's deemed to be greener than normal from space. The agricultural areas are kind of a bit, there's a lot of this kind of fawn, yellow, white. So there's this kind of, it is greener in parts in some paddocks, but it's also deemed perhaps a bit less. I suppose they're the ones that have been sprayed out or have been, or they've got stubble sort of perhaps on them instead as the predominant feature. But certainly your natural areas have boomed as a result of that rain, are sort of greener than normal. Right, let's go to climate now. This is the absolute temperature of the ocean surface. Cold water at the poles, much warmer water at the equator because the sun is what's heating that up. And 30-degree water up here in the Coral Sea in the Western Pacific, and 30-degree water through most of the Indian Ocean along the equator. And even some 31-degree water up here off the coast of India and Sri Lanka and Southeast Asia, Malaysia. Only 20-degree water here in the Gulf the Bight. And the reason this is important is because water's got to be over 24 degrees to get any meaningful evaporation off it. So the areas I've marked here in the blue lines are the world's engine room for rainfall. This is where the vast amount of evaporation has come from and does come from. It's really not, can't come off anything sort of to the south of us because it's simply not warm enough. This is an animation here of the sea surface temperature anomaly. So that's same data before, but we're now looking at how warm it is compared to normal. This image was starting off, I think, in December or January. We had a colder than normal blob there, this one here. And we can see over subsequent months that has slowly eroded out. We've got some warmth sort of appearing off the coast of Ecuador, but not excitingly so. We can certainly see that things up here in the Coral Sea have been warmer than normal around. There's been a lot of cyclone disturbance there at times, which would then cool it down a bit, but then it reverts back to normality pretty quickly. And over in the Indian Ocean, at the moment, things are sort of pretty much warm across that whole basin. We did in March have some positive IOD light activity with that cold water appearing there, but that disappeared pretty rapidly as well due to the wet season stirring that up and disturbing it. So at the moment, we've got nothing going on in the Indian Ocean. We have nothing going on in the surface of the Pacific either. It's currently the relative measure of this Nino 3.4 area, which we measure for the El Nino and La Nina, is currently plus 0.23 degrees, so slightly warmer than normal in this box, which is where we monitor for things like an El Nino. Things just warmer than normal everywhere in the Indian, but still things still warmer than normal in the Coral Sea. But that warmth has sort of moved a bit further outwards. It was closer to Australia. And of course, sitting where you are, you're probably going, why is he talking out here? Surprisingly enough, the vast amount of moisture we see evaporating out of the Coral Sea drifts through with the trade winds. And when we draw it down in a northwest cloud band, it looks like the moisture is coming out of the Indian Ocean, but it may have in fact and often has evaporated in areas a lot further away from you than that. That's not to poo-poo the Indian Ocean. That's absolutely important. It's certainly more important for frontal activity for you as that's coming through. But both the Pacific and the Indian Ocean are equally as important when we get to decent rainfall that's being drawn in from the north. This is this is another time-lapse image, but only over a few days. This is showing moisture in the atmosphere. Total, if you wrang all the water out of the atmosphere, that could actually form as rain in these purple and orange bits. This is where it is, and you can see that over most of Australia, there's nothing going on there in terms of real precipitable water. We can see some storms around Antarctica spinning, pulling moisture out of the tropics, which is what they do when they're getting a northwest cloud band or forming a front. And you can see a little bit sort of streaming around there. But I hope you can also see the fact that moisture flow is drifting through this way. And it's sort of drifting right through there at the moment, which is something we'll talk about soon, right through to, but it's quite possible that some of this moisture that's coming through here is actually evaporated up in this zone here before it comes down. The astute of you among you, I hope, are looking in the centre of Australia at Lake Eyre. This is a question we received, and you can't see any meaningful evaporation coming off Lake Eyre. Lake Eyre, as big as it is compared to what's going on up here is just too small. Even though it's big, but it's too small compared to the ocean. And so, yeah, as a moisture source, Lake Eyre is nothing but a pimple. And the reason Lake Eyre is full is because it's rained a lot in the Channel Country, and it rained a lot in the Channel Country because the ocean was particularly warm, and we had a La Nina pattern over summer, which aided that. And we had some low-bearing systems that sat over the Channel Country for long periods of time, which is why it has been so wet there. So the million-dollar question is, well, do those effects last into the coming season? Because it happened over summer, we hit reset mode. The reality is that any effect over summer there is very unlikely to be going forward into the current season. The one thing that is a bit might be still hanging around is the fact that the ocean up here in the Coral Sea has been incredibly warm for the last 5 years. And so there's a lot of talk of an El Nino forming, which would be cool water through this zone. And let me get that right. Warmer water, 0.8 degree warmer than normal water in this zone, which historically cools off the north of Australia and switches off our moisture zone. But the million-dollar question this year is, can whatever happens out in this Pacific Ocean actually cool things off out here, which we've not been able to see for 5 years? It's been a kind of a perennial pattern out there and a bit of a bogey in the mix, which is a bit different to the classic sort of El Nino. And we had 3 La Ninas in a row, which sort of built that heat up, and it hasn't really dissipated yet. But you can see the warmest parts of the ocean of the world are where all that moisture is kind of evolving at the moment. You see large amounts there in the Indian Ocean, much more than we saw for most of summer, really, because that ocean is much warmer than normal out there at the moment. This is a time lapse of the undersea. We've got 3 oceans here, the Atlantic, the Pacific and the Indian, the land masses of South America. We've got Indonesia here, we've got Africa. Let's concentrate on the Pacific Ocean first. And we see when we get to the start of this animation, there was a cool anomaly sitting here. Hopefully that will appear soon. There it is, the remnants of the La Nina. That was the last bit of it. We had some stronger than normal westerly wind reversals in January up here in the Coral Sea that pushed warm water underneath and sent it on its way. And you can see it there, going along, moving away, coming up and popping up, starting to upwell at the surface, which is where we've seen that warmth coming off Ecuador and a little bit sort of coming across the surface. But we don't see anything really going on in the central Pacific Ocean there at the moment. Everything's kind of underneath there. When we have if and when we get a proper El Nino, we'd expect a big warm anomaly right underneath this zone, but at the moment it's much deeper than that. And so this is a pre-El Nino signature. This is where the models are pulling their El Nino from. If you're going to have an El Nino, this is what happens. This is what you see going on. But I'm at pains to point out that this doesn't guarantee that one forms. You've got to see this if you're going to get one, but it's all about trade wind activity up this part in the Coral Sea. We need to see sustained westerly wind activity, which does 2 things. It pushes that warm water underneath, and the other thing it does is it collides with the easterly trade winds coming from this direction, calms the ocean up here, and allows the sun to get in and warm it up at the surface as well, which is kind of what we, don't sort of see at the moment. We've got a bit of warmth coming in from this side. We've got warmth over here, but sort of what's going on in the middle here is a bit kind of nuff-nuff. So we need to see stronger westerly wind activity and reversals of the trade winds, which have been at the moment January. There's been one this month or last month as well. They're very much weather phenomena at the moment that are driving those westerly winds until the system kind of locks in and sort of more permanently starts working together. But we simply see no evidence of that. Over in the Indian Ocean, things are warm at depth. And, that doesn't look overly positive Indian Ocean dipole-like at the moment, where the models are all leaning. where would be, cooler water potentially at the surface off Indonesia. But the positive iodide or the Indian Ocean dipole can happen in a month if it starts to kick off, and could well be driven by more surface and atmospheric things rather than the undersea, and the undersea might follow what happens in the atmosphere. Looking at cloud patterns, looking at the junction of the dateline and the equator, there is it's average amount of cloud there. If we had an El Nino, some of the warmest water in the world would be sitting right here, and there'd be an abundance of cloud in that zone, and we don't see that yet. So the atmosphere, in terms of the cloud, is just behaving itself normally. This is kind of still that hangover of that warmer water in the Coral Sea, still a bit more cloud around there, but that really has shrunk from what we saw over summer. We now see quite a large anomaly of a lack of cloud in the northern hemisphere of Southeast Asia, but there's almost no connection with what happens there with us. There's almost a wall along the equator here that the northern hemisphere doesn't talk to the southern hemisphere climate. Although we do see a lack of cloud through Indonesia and a lack of northwest cloud band activity there into New South Wales, of which, that's probably one of the driest parts in the country at the moment, right where that blob is there. If we are to see a positive IOD, we would expect to see an eye forming more that colour here, sitting in this blue box off Indonesia, or an abundance of cloud off Africa, and we simply don't see that at the moment either. It will be interesting to see whether this cloud pattern is just a remnant of the wet season, where a phenomenon called the Madden-Julian Oscillation, which is a cloud wave that takes 40 days to travel around the equator, and is kind of sitting kind of out here at the moment, and leaves a less cloud and a drier pattern to the north of Australia. So we have got to the end of the wet season. We shouldn't see any more tropical cyclones now in theory, and we should start to see, winds and pressure and those kind of things kind of behaving themselves and not being affected by tropical disturbances, which is what they do up until now, essentially, which makes autumn, once again, a very hard time for predicting. Looking at winds, in the last 30 days, we have had some stronger westerly wind in this area here. There was, people following social media might have heard people getting very excited about that. And that has probably almost certainly put some downforce on that part of the ocean and sent some warmer water underneath. But it was very much localised. There were two cyclones spinning up here. We had one spinning here, one spinning there, and that was what was drawing that wind out from that area. But you can see that didn't go very far into the Central Pacific. And because of that, there's been no real warming going on out here, and it's been much more localised to that area there. So if we are going to see an El Nino, we are going to need to see much stronger than normal westerly wind right across the Pacific, perpetually going on with very little break for much of the rest of the year. Now there's plenty of time for that to start happening, but it's certainly not happening at the moment. In the Indian Ocean, nothing's going on in the 30 days. If we look at the last 7 days, there is some stronger than normal easterly wind going on in this area at the moment, which is going to be worth further watching just to see what happens. That's what we might expect to see, something potentially kicking off some cooler upwelling of water in this zone here at an interesting time of the year. So early days is what that might be causing, or might cause, or may not. If it's a flash in the pan, it might do nothing. If it continues and going on, I'd expect we would see cooler than normal water forming here, and that could be enough to start kicking off some sort of positive IOD-like event. But we will see whether that's a sustained easterly wind movement there or not. Moving to a phenomenon called the Southern Annular Mode, which is a measurement of the sort of the winds spinning around Antarctica and the frontal systems and their proximity. Probably, to be honest, something that affects the southern half of the EP more, and probably really just the coastal bit down at Port Lincoln more than other bits. Certainly affects the southeast of South Australia more, that Mount Gambier region more likely, more often. Has a few different phases. Has a positive phase, which is when it's sitting up in this zone, a negative phase when it's down here. Has activity that is more meaningful in summer and winter, and autumn and spring is kind of a shoulder season where its behaviour is more erratic and often means a bit less. We've had negative phase through April. Not sure if that's done anything. In summer, negative phase would mean systems have been pulled further south, and maybe that's what in fact has been going on. At the moment, we're just sort of weekly positive here now. This American model predicts it to sort of dip down to normality and go positive. The Australian model sort of predicts it to just to sit sort of weekly positive from now on. Certainly once we get into winter, at the other end of May, positivity in the southern annual load would be something we wouldn't be wanting to see necessarily, meaning that systems have been pulled further south. But at the moment, I think it sort of doesn't mean too much. Where we have had an issue, as we often do in autumn, is pressure. There's been on average over the last month, a high pressure cell spending more time than not over Victoria, South Australia, meaning that more often than not, weather systems have been heading south. So that is, that's a blocking position of that high pressure pattern. The centre of the high pressure is a winter pattern would be the top of the Bight, an autumn pattern would be about Adelaide, a summer pattern is around Melbourne. So this pressure ridge is hopefully moving south over time into winter up to its position at the Bight. So arguably normal positioning there of the latitude of the pressure ridge, and you can see that pressure ridge right through here. But just a crappy position of that actual high sitting more often than not in somewhere you would rather that wasn't, sending the triggers south. If we look at the anomaly of pressure, a few things to note here. We look at the Southern Oscillation Index, which is the pressure at Tahiti and the pressure at Darwin. And in the last month, that has rapidly fallen to negativity. We've got higher pressure at Darwin, lower pressure at Tahiti. So the SOI is negative 11.7, where a value for El Nino-like pressure would be -8. So we are below that threshold. That is not a great sign, but once again, we've only just got to the end of the wet season, and it is too early to know whether this is the pressure pattern locking in for some sort of El Nino-like behaviour, or whether this is just a leftover from the end of the phase of the wet season we were in. So bears watching, but not being megally alarmed about that yet. Actual pressure has been a bit mixed. It's been lower pressure to the south of us, or south of you, bit higher pressure through parts as well, but not a real lot sort of in that. It's been generally lower pressure over southern Australia for most of summer. So this is a bit unlike the last two autumns where we've had really high pressure anomalies sitting over the top of you and things were all sort of heading south. So at the moment we've got a bad position, but at least it's not higher than normal pressure. So just in summary there's two phenomena that are being predicted we'll see soon by the models, an El Nino and a positive IOD. Both of those often happen together in some years. But at the moment, the El Nino, I think I've shown there's some warmer temperature to depth, and the pressure pattern is not at the moment looking that great either, but the ocean surface, the wind directions and the cloud are all doing nothing. And until we get, at least 4 out of 5, or at least probably 5 out of 5 of these kind of phenomena bits acting together, we won't have a proper El Nino, and we're nowhere near a proper one at the moment, when they're generally measured by what happens at the surface. And in terms of the Indian Ocean, well, there's nothing going on there at the moment at all. Rightio, let's move to actual predictions. All the models have done their April runs. We're looking at predictions for May, June and July. And it's fair to say that model skill for the Eyre Peninsula is not good at this time of the year. In fact, Victoria is probably half and half between moderate skill versus low. And by low, I mean none. Flipping coins better than more accurate. It's interesting to note that the Bureau's model is in fact the most accurate of the models at this time of the year. And we can see that almost all models are predicting, well, actually all of them are predicting an El Nino of some sort forming in the next 3 months. And nearly all models are predicting a positive IOD as well. So 2 known climate drivers that are possible for causing drier conditions. It's important to note that just because the models are predicting these 2 things, that does not mean they will form. If anything, the last 3 years has absolutely shown us that, or last 2 years in particular, but yeah, 23, 25, last 3 years really. Just because the models are gunning for something doesn't mean it will happen. If we look at rainfall though, well, there is a consensus of a lot of models for rainfall being in the driest third of the record. We have ensembles of models here which look at, maybe 6 to 8 models around the world. These are averages of a number of models. So when they're going on saying something, it's not just one model, where these ones up the top here are just one single model. You can see the Bureau's model that as of this morning, that model has flipped to be a bit more drier over more of the Eyre Peninsula. We'll see that coming up soon, but it's not a strong signal, as we'll see. But some of model, this one here, the European model, has got it's much more emphatic about a lot more of the model runs predict that the rainfall will be in the driest third rather than just a higher percentage than normal. We'll talk about that soon too. Unsurprisingly, with El Nino and positive IOD, drier and warmer conditions as well usually go hand in hand, which is what the models are predicting. It is interesting it'd be interesting to note as to whether there's some pressure patterns mucking around going on here, as often is what manifests. How is it actually drier when these 2 phenomena form? Well, we get a few things happening. One is we often get cooler ocean temperatures to the north, and we often get higher pressure sitting over the top of us. So one stops rainfall actually getting to you, and the other is that when it actually happens, there's not as much that you can drag down. And often that pressure response is probably more than just the lack of moisture availability to our north. The real crystal ball gazing, which has almost no skill at all at this time of the year, keeps that El Nino going, positive IOD going as well, drier signals and warmer signals too. So nothing unsurprising with the predictions you've got there. But I want to emphasize that just because the models are predicting doesn't mean it happens. And even if we do get an El Nino starting to form in the Central Pacific Ocean in terms of the warmth, does it mean the winds, the pressure, the atmospheric things are linking up, which is what we've not seen in the previous 3 years, where the ocean or the atmosphere is doing one thing, singing from the hymn sheet, but the other atmosphere or ocean parts are not. And so if you're not getting this coupled ocean atmosphere phenomena, well, the likely predicted outcome is not as good either. So at the moment, it looks like the models are wanting to form these events and get them coupling up between the ocean and the atmosphere, but that doesn't mean that will happen. So let's just look at a few different ways of looking at the current forecast. This is the May to July forecast from this morning from the Bureau. This is the map of what's the chance of exceeding median rainfall. We can see that, there's brown on the screen, and the brown on the screen doesn't say how much rain it will be. It's saying what's the chance of exceeding the median or the average rainfall. And what you instinctively need to do with this map is subtract this number from 100, and that's the chance it will be wetter than average. So, you know, if you're 40 to 35% of exceeding the average, you're actually 60 to, I've got to do my maths here, 60 to 65% chance of actually not being above the average, of being drier. Down here, you can see there is a drier signal for the tip, which is in this 25 to 30% chance of exceeding median or average, meaning it's really an 80 to 75 to, sorry, no, a 75 to 70% chance of not exceeding the average. And of course, that doesn't mean that the exact opposite could not happen, but it's just at a lower probability. So this is what's called a binomial distribution, your plus or minus average. There's only two possibilities. There was a different way of looking at this forecast. Excuse me. This is a tercile distribution. Probably should have got a glass of water, but didn't. Too bad. This is showing what the probability from the models is of being in the lowest third of the record in brown, the middle third, average rainfall in grey, or wettest third of rainfall in green. This is what's called a tercile forecast. And you can see that while there's a percentage of being less than the median here, less than a 50-50 chance of being average, there's actually an increased chance, there's a 40 to 50% chance that you will actually be in the lowest third of the record. So that's sort of telling you a bit more information there. The other thing that you can do, and I hope you know that that's possible, is you can either type into the question mark up here, type in a location, or you can press anywhere on the BOMS map, and you can bring up a quintile or a sort of a decile, or it's a map of fifths. So of the last 99 runs of the model, they're binning that into decile 1 and 2, the drier end, decile 5 and 6 in average, or the decile 9 and 10 in wet. And just for instance, I took this brown a bit over here at Alliston. I probably should have chose down here, but I chose Alliston instead. Type that in, and we can see that the chances of being decile 1 and 2 are increased above the 20% of normal by definition. Decile 3 and 4 rainfall is about average. Decile 9 and 10 is not far from average. Average rainfall and decile 7, 8 are a bit lower. I think that's what frustrates people, I suspect, is when I say that the model will not be wrong. The future lies somewhere there. We just don't know where. Some perhaps increased odds of it being drier, but the odds of it being wetter are not that decreased either. So it's a very much a vanilla milkshake, although I love vanilla milkshakes, kind of forecast. Is that the odds have not dramatically really shifted in a particular direction. And sometimes they do. Sometimes they're very dramatically switched into drier, and there might only be 3 model runs that are going wetter. At the moment, you've still got quite a few. So, it's close to a forecast of anything could happen, which is, I think, better than looking at that map there and going, gee, it's brown, it's going to be drier. No, it's not what that model's saying at all. If you've been listening to Peter Heyman at all through your lives, you would know it is all about probability, and that these models are not emphatically saying what will happen. They are running it 99 times and getting a range of outcomes, and you see a spread of those in both this model, a way of presenting the model information, and this one, and this one. And all three are the same, but all three are telling you something a little bit different in terms of, really how far things are swinging or not away from normality. The last thing I want to sort of go is just speak about this hoopla about Super El Nino, which is not remotely helpful. We hear it all the time, particularly this time of the year. And it's true that some models in the world are predicting a strong El Nino this year, which is a measure of the Central Pacific Ocean about how warm that will be. So an El Nino is 0.8 degrees warmer. A super one is 2 degrees warmer. Some models are predicting up to 3 degrees warmer. And I think in the minds of the media and people listening is intuitively they're thinking strength of El Nino has some correlation to strength of drying. The good news is that that is not true. There is very poor correlation between the strength of warming in the middle of the Pacific and how strong the El Nino will be and what any drying effect could be. Of course, the issue is if you get any El Nino, that swings the odds of drier being higher. This is the June to October rainfall in little tercile maps here, where the red pieces of these pie charts are where the rainfall's in the bottom third of the record. And you can see that pretty much across the whole EP, if you just get an El Nino, the season's rainfall spins up, instead of being a third drier, which is normal, spins up to 50, maybe as close as 60%, sort of twice the odds of it being drier. But you can see blue and yellow bits of these wedges here, which means that average and wetter have occasionally happened. And if we have a positive IOD, those graphs arguably don't change as well, much differently. And I suppose the other thing is if we have an El Nino, this data comes off of a website we did with GRDC a few years ago with Peter Heyman called the Local Climate Tool. You can look that up. You can look at these different locations on the EP and click on them and interrogate the rainfall to your heart's content to see what these climate phenomena have in fact meant for your location. This is really the truth tester. And if we just look at, I looked at Loch here in the centre, there's Loch, and looked at El Nino just by itself and looked at the spread of deciles of rainfall, you can see that a quarter of the years historically, 28 that have been El Nino, 25% of those have been decile 1. I would say they were the droughts. They were pretty ordinary. But that's 25%. It's not 50. It's not 75. A quarter of the years have been terrible. If you're a glass half full person, you would say that, more than 50 to 60, 70% of those years have kind of been decile 3 or wetter. And that's the more likely outcome, in fact, that things are likely to be better than terrible. So I think we fixate on this end and forget that, in fact, the upside is probably greater. And of course, this depends how it pans out. At the moment, we have no idea whether there will be an El Nino. So therefore, we're looking at all years, which is, there's a 10% chance of anything of happening here at the moment, in the absence of any other information. If we had an El Nino forming, well, then the odds kind of spin up more like this. And then that's history, of course, and the models at the moment, or the models probably have got a bit better way of teasing out whether the way things actually form in terms of atmosphere and ocean puts us kind of down in this end, or, more in this end, or maybe it could be, maybe neutral or wetter is even possible. Who would know? But it's only the models that got really a way of teasing that out. This is the positive IOD one down here, you can see that that's not dramatically. It's probably a bigger section of decile 2 than for El Nino there. And if you have both of them, well, there's, a larger, maybe a third of the years, if you've had El Nino and positive IOD, have been decile 1. That's a smaller number of years that's actually occurred in terms of the record. So that's getting to the end, Naomi. So just in summation, an El Nino and a positive IOD are predicted. There's no sign of them forming yet. There is evidence that an El Nino is at least possible with that undersea signal, but we need to see a lot more reverse trade wind activity up there in the Coral Sea for that to kick in and sustain itself. At the moment, there's not much evidence of what might happen in the Indian Ocean. Even though one's predicted. But as I said, the Indian Ocean can flip very quickly in a month. Pressure patterns currently unhelpful. It would be good if that changed and moved away, but dry seasons are often dictated by what the pressure patterns get up to. And most models are predicting drier and warmer conditions. But I suppose the good news is with that moisture profile that a lot of people have got locked away there, getting crop in and out of the ground wouldn't take, we could probably do that with drier rainfall, as long as it actually happened, and keep things going. And, you know, we probably saw that last year, I suppose, although your profile perhaps wasn't as good, but we certainly saw that in Victoria, that with a full profile or with a wetter profile and some drier rainfall, decile 2, 3, the season can still be perfectly okay as long as the timing of that rainfall is kind and the spring is not too hot. Anyway, we'll leave it there. Hope there's some time for some questions there, Naomi, and happy to take any if there are.
Thanks, Dale. We probably went a bit over time there and have officially run out of time. So totally understand if people need to jump off. We did get a question during the session. To this point, in terms of likelihood, the so what is that the 2026 El Nino will be a non-event the same way it was in 2023?
Well, that's a good question. That is a good question. So this is some predictions from the models, North American models here, the Bureau's model down here, overlapping for the same sort of period. And you can see in 2014, the coloured bars are the predictions and the black line is what actually happened. So 2014, lots of predictions of El Nino, didn't happen. 2015, this time of the year, the end of May, we actually had a fully functioning El Nino. Was well predicted, absolutely happened. 2017, predicted, didn't happen. 2023, predicted, didn't happen until Christmas time almost. 2025, predicted, didn't happen then. I'm trying to think last year. No, last year wasn't. That was all about La Nina last year, sorry. So just there's 4 years where the models like predicting them at this time of the year, at the worst time of the year for prediction, and they're about 50-50 at the moment at getting them right. So I don't think I could confidently say that this is a non-event. I think the problem is we see the way the ocean is set up, it's a plausible possibility. And at the moment, I'd probably put it at 50-50. I think there's no chance of seeing a La Nina this year, the way the ocean is set up in the undersea of the Pacific. But I think a neutral Pacific Ocean or an El Nino is possible. And it's, of course, a big pains to say that a neutral Pacific Ocean doesn't mean it's going to be an average year. We've had dry seasonal conditions in neutral years. In fact, I think so neutral, these are the neutral years here. Very few actual decile 1 years, at least in neutral years, but there's certainly been decile 2 seasons in neutral years. So there's a little bit of upside there, I suppose, in terms of it is neutral. And I think that's where we're sitting. It's either this one or this one, but it could be a positive IOD could form as well too. So I think there's cause for caution, but sitting with the profile that a lot of people have got, I don't think I'd be too pessimistic quite yet until we saw some evidence of these things actually forming, not just talk of them forming.
Great, thanks, Dale. And a follow-up question to that then. So we are catching up with you again on the 22nd of May. Does that mean, I guess we'll have a quick review of where things might have changed and if there's more confidence or less, or?
Well, I think the problem is that the accuracy of models, still memory, I don't think it gets that much better. Okay. It's really July where we get the purple patch. Of course, the crop will be in and out of the ground, hopefully, and growing by then. And we'll be looking at the very end of nitrogen top dressing. That's if we can hopefully get some and need it. So it will be just a case of watching these phenomena and the measurements, really, rather than the models, watching the measurements of what is going on in the world. Is this thing forming as predicted, or is it mucking around like it has in the previous 3 years? And the longer it mucks around, the more that buys you the time that it ain't forming in time to affect things.
Fingers crossed. I don't think we have any other questions in the chat. Do we have any in the Q&A? No, I'm not seeing any more. And given that we're probably about 10 minutes over time, I might call it there. People will have access to the recording. We'll send that to everyone and probably make it available through the newsletter. Thank you very much, Dale, for making yourself available today and for doing all the stats and the work behind the scenes. There's a fair bit of work that goes into these things, so thank you very much. Thank you all for participating. Also, thanks to the EP Landscape Board and the Australian Government Natural Heritage Trust for funding the project that allows us to bring this information to you. We do have more coming up, so if you do have suggestions or ideas for topics that you'd like to hear from, we've got a number of these scheduled over the next couple of years. So we'll all be experts in climate by the end, by 2028. Yeah, just swing them through or put them in the registration form when you register for each of the events. Thanks again, everyone, very much, and thanks, Dale, and good luck for the season, everyone.
Yeah, all the best. I hope a rain comes through soon to get everything up and away.
Correct. Thank you all.